Questions 1 through 4 on the 2004 Grade 12 Euclid Math Contest. In the diagram, what is the area of figure ABCDEF? So the first thing to do is probably divide this into a couple sections like that, and that will help us a little bit. A lot of this has already been labeled. This is 4 and this is 8, and if that is indeed the case, then DE will be 4. And now to figure out this area, this is of course just a square, 4 by 4, and add to that the area of this rectangle, and that is 4 times 8. So this is 16 plus 32, and therefore the area of that total figure is 48. In the diagram, ABCD is a rectangle with AE equal to 15, EB equal to 20, and DF equal to 24. What is the length of CF? This side, AB, I can calculate because I have a right triangle right here, ABE. And therefore that will be, using Pythagoras, 15 squared plus 20 squared, like that. So this gives me 225 plus 400, which is 625. And therefore AB, if you take the square root of that, will be 25. So I'll write that in there like that. And now, since this is a rectangle, DC is also 25. And now I can once again use Pythagoras to calculate FC, our required length. And therefore it will be FC squared plus 24 squared equals the hypotenuse squared, which in this case is 25. So FC squared plus 576 is equal to 625. And if you subtract them, you get 49. And therefore FC, if you take the square root, is equal to 7. In the diagram, ABCD is a square of side length 6. Points E, F, G, and H are on AB, BC, CD, and DA, respectively, so that the ratios are all equal to 1 to 2. What is the area of EFGH? We can start labeling. We know that AE to EB is 1 to 2. So if AE, for example, is x, EB is 2x. And in a very similar way, it's identical all the way around if you just follow what is written in the question stem. Now ABCD is a square, so these are all right angles. We know that. And then now I have to figure out the area of this shape. Now they don't tell me actually what shape that is. It doesn't look like a square, but it is a square. Why? Because if you were to calculate the length of EF using 2x and x, the length of EF is going to be the same as the length of EH, HG, and FG, because those triangles are all the same. They have the exact same lengths. So all I'm going to do is just calculate one of them. So I'm going to basically, any one you want. This one is perfectly fine, EBF. So let's do that using Pythagoras. And therefore EF, I'll just label it Y, is equal to 2x squared plus x squared. All right, I'll put on a y in there just to make it a little bit simpler. 4x squared plus x squared when I do that square. Now, I don't have any numbers here, and I'm pretty sure they want me to figure out an actual number. So that's where this comes in, right there. That whole length is equal to, they tell you in the question, it's 6. So therefore x plus 2x is equal to 6. And therefore 3x is 6, and then x is 2. All right, so there you go. We have the value for x. Now we can calculate y. It will be 4 times 2 squared plus 2 squared. So it looks like 4 times 4, which is 16, plus 4. And this is 20. And remember, if EF is y, what I really was doing was y squared. So I have to make sure that is consistent. And therefore y is equal to the square root of 20. Now if you calculate these sides, they're all y. So therefore that is a square. And the area of, therefore, that square, and E, F, G, H are the vertices, will be just y times y, which is y squared, and y squared is equal to 20. A horizontal line has the same y-intercept as the line 3x minus y is equal to 6. What is the equation of this horizontal line? So I've got my little coordinate axes here, x and y, and they're saying that 3x minus y equal to 6 has the same y-intercept as some horizontal line. So first let's figure out what that y-intercept is. How do you figure out the y-intercept? You set x to 0. And if we do that, we get 3 times 0 minus 6 is equal to y. And that just looks like minus 6 is equal to y. So that means somewhere in here, say if this is minus 6, that is basically where our line is. And it's a horizontal line, so it will be straight across like that. And that's pretty much it. I believe this line goes on forever in each x direction, and its equation is y is equal to minus 6. And that's pretty much all there is to this question. They just want the equation of that horizontal line. In the diagram, line A has the equation y is equal to 2x. Line B is obtained by reflecting line A in the y-axis. Line C is perpendicular to line B. What is the slope of line C? So first and foremost, line A right here has the equation y is equal to 2x. Now if you reflect it in the y-axis, as they are saying in the question, you get line B. And line B, we want to know its equation. All right, well, think about it for a second. If you have any point on the x-axis and you rotate it or flip it or reflect it, whichever word you want to use, in the y-axis, it'll go exactly to the other side, the same length, same distance. So for example, if this was 3, this would be minus 3. Okay, that's what it means when you reflect it in the y-axis. So instead of putting in x, you're going to put in minus x, like that. So the equation of line B is basically y is equal to minus 2x. Okay, and now they want you to figure out the slope of line C. You say, well, how do I do that? Well, they tell you it's perpendicular. So a big right angle right there. Now this equation, y is equal to minus 2x, tells you the slope. Why? Because every equation of a line is of the form y is equal to mx plus b, where m is the slope. And in this case, m is minus 2. So our slope is minus 2. And I'll call that mb to represent that it's the slope of line B. Now the slope of line C, because it is perpendicular, its slope is, some of you remember, negative reciprocal. So the negative reciprocal of that, so you take the reciprocal and then you add a negative, and therefore that just becomes positive 1/2. And that is basically going to be the slope of line C. So I'll write it like that, MC. So there you have it. Part C of number 2. 3 squares, each of side length 1, are drawn side by side in the first quadrant as shown. Lines are drawn from the origin to P and Q. Determine with explanation the length of AB. So here's our diagram, a little bit larger. And O here, of course, has the coordinates 0, 0. P, if you look at the graph, has the coordinates 2, 1. And Q would have the coordinates 3, 1. So those we can figure out from the information they've given us. and everything else they've already labeled. B, we don't know the coordinates, but I do know the x-coordinate. The x-coordinate is 1, so it's 1 and some value of y. We'll call it y1. And A, in a very similar way, we know the x-coordinate is 1, but the y-coordinate, I don't know, it's y2. So as long as I'm able to figure out y1 and y2, I can then figure out their distance, because that would just be the distance on the y-axis. So for example, if B were to be extended till here, that would be y1. And if A, you extend the line to here, that would be y2. And as long as you know those two, y1 and y2, the distance from A to B would be just y1 subtract y2. Okay? So that's the plan. Now, how do we figure out those coordinates? Well, we have to figure out the equation of those two lines. The first line, of course, is this one right here, O to P. All right, let's do that. OP is my first line. Now, all lines are of the form y equal to mx plus b, correct? So we can fill in points and get m and b. Well, the first point I'll put in is 0, 0. And if I do that, I just get b equal to 0. So this line is essentially of the form y equals mx because b is 0. Now, if I want to find the equation of line OP, I'll use this point to figure out my m. So when x is 2, y is 1, like that, and therefore m is a half. So the equation of this line is y is equal to 1/2 m. Okay? So I hope that was not too confusing. And now we can figure out what is y1. Substitute that point when you have y1, x is 1. So we have 1/2 times x, and there you go. y1 is equal to a half. So I'll just put that in there like this, a half. And there you go. So we're halfway done. Now, in the very similar way, we've got to figure out the equation of line O to Q. So I'll do that over here, OQ. And as we know, the line is going to be of the form y equals mx plus b. First, let's substitute in 0, 0. If we do, we get 0 for the value of b, and therefore this equation is just y equals mx. Now let's substitute in that point to figure out m in this case. When y is 1, x is 3, and therefore this slope is 1/3. So this line is y is equal to 1/3 x. Now I plug in that value for the coordinates of A to figure out y2. If you have y2, it will be 1/3 times x, and x is 1, and therefore y2 is 1/3. So there you go, put in 1/3 right there. And now I can figure out the length of AB. AB is just y1, which is a half, minus 1/3, and this is equal to 1/6. So that is the length of AB. In an arithmetic sequence with 5 terms, the sum of the first 2 terms is 2, and the sum of the last 2 terms is -18. What is the third term of the sequence? So we have 1, 2, 3, 4, 5 terms. First term, of course, would be a plus d. A plus d would be the second term, rather. A is the first term. And then a plus 2d, a plus 3d, a plus 4d. These are our first 5 terms of an arithmetic sequence. Okay? And they tell you that the sum of the first 2 is 2. So if you add these up, you get 2. So a plus d is equal to 2. And then they tell you that the sum of the last 2 terms is -18. So if you add these up, a plus 3d plus a plus 4d, you get -18. Okay, we got 2 equations, 2 variables we can solve. And then in the end, we have to figure out the value of the third term. All right. So let's first solve for a and d. So this equation looks like 2a is equal to 2 minus d. And this one over here looks like 2a plus 7d is equal to negative 18. So that means 2a is equal to negative 18 minus 7d. All right, we got 2a is this, 2a is that, so they must be equal to each other. So 2 minus d is equal to negative 18 minus 7d. Bring the 2 over and we get minus 20. Bring the 7 over and we'll get 6d. And therefore d is equal to negative 20 over 6, which is also in lowest terms negative 10 over 3. All right, we can now plug it back into here to get our value for a. 2a is equal to 2 minus d, which is minus 10 over 3. Correct? And then this becomes 2 plus 10 over 3. If you want to add this, get a common denominator, and we'll get 16 over 3 is equal to 2a, and therefore a is equal to 8 over 3. There you go. You got 8 over 3 for a and negative 10 over 3 for d. Now we can figure out the third term. The third term is right here. It is a plus 2d. So a is 8 over 3 plus 2 times d, which is negative 10 over 3. 8 over 3 minus 20 over 3. And we get here minus 12 over 3, which is, of course, negative 4. So there you go. This is the third term of that arithmetic sequence. If x minus y is equal to 4 root 2 and xy is 56, determine the two possible values of x plus y. So x plus y is what we want to figure out. Now, these terms look very familiar to me. I've seen them somewhere, right? And a little bit of algebra over the years will definitely remind you that this xy appears when you expand x plus y. I'm sure you've done that many times. And then in a very similar way, if you expand x minus y, you get something similar, except it becomes minus 2xy. Okay? Now, the good news is that this we are told and this we are told. Correct? They give us that information. So x minus y is 4 root 2, all squared. X squared plus y squared we are not told, but we are told xy. It's 56. So I can solve for x squared plus y squared. So 4 root 2 squared is 16 times 2, which is 32. And then 2 times 56 is 112, so minus 112. If you bring it over, it'll become positive 112. And therefore, this is 144. X squared plus y squared. All right, I just have to plug that in there. So let me bring that over here. I think that should be enough space. X plus y all squared is equal to x squared plus y squared plus 2xy, correct? X squared plus y squared, we just figured out, was 144, plus 2 times xy, which is 56, as given in the question stem. So we have 144 plus 112, and that is 256, and that is x plus y all squared. And therefore, if you take the square root, you'll get plus or minus 16. And those are indeed the two possible values for x plus y. 2 fair dice, each having 6 faces, numbered 1 through 6, are thrown. What is the probability that the product of the two numbers on the top faces is divisible by 5? In this question, I think doing it in a complete way will be the best way, instead of trying to explain, well, when there's over a 5 on the dice, it will be a divisible or product or whatever, and it just becomes so abstract. Why do it that way? Just do it in the complete full way, and it becomes completely clear. And it can be done very quickly. All you have to do is write out all the combinations, and you can do that in less than a minute. How many combinations are there? Well, there's 2 dice. Each of them are going to be thrown. When you throw the first one, you have 6 possible outcomes, 1, 2, 3, 4, 5, 6. And in a very similar way, the second dice has 6 outcomes. And you multiply them, and you get 36. So since this is a probability question, the denominator will be the total number of possible outcomes, and in our case, it's 36. Now I have to just figure out what is the numerator. And the numerator has to meet our condition, which is that the product of the 2 numbers on the top faces is divisible by 5. All right, let's do it. Let's figure out all the possible outcomes. If the first dice is 1, second dice can be 1, 2, 3, 4, 5, 6. Correct? If the second dice is 2, if the first dice is 2, the second dice is 1, 2, 3, 4, 5, 6. If the first dice, when you roll it, is 3, then our second dice has 1, 2, 3, 4, 5, 6. Well, you get the point, right? So I'll just do out the rest. So there you go. Very quickly, you get all the 36 possible outcomes. And then for each of these, we have to figure out the product of the 2 numbers. We can do that very quickly. 1, 2, 3, 4, 5, 6. That's the product there. 2, 4, 6, 8, 10, 12. That's the product of those. 3, 6, 9, 12, 15, 18. Next one, 4, 8, 12, 16, 20, and 24. 5, 10, 15, 20, 25, and 30. And finally, 6, 12, 18, 24, 30, and 36. Now, let's circle all the products that are divisible by 5. 1, 2, 3, 4. All of these guys. And that one right there. So how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And there you go. That's the probability that they are looking for. 11 over 36. If f at x is equal to x squared minus x plus 2 and g at x is equal to ax plus b and f at g at x is equal to 9x squared minus 3x plus 2, determine all possible ordered pairs A, B which satisfy this relationship. Okay. So f at x is equal to x squared minus x plus 2. And g at x is equal to ax plus b. And they want you to figure out f at g at x. And they give you that it is equivalent to 9x squared plus minus 3x plus 2. All right. So that is going to be very helpful. I will now concentrate on this side because this side has already been given to me. This side, I use this equation. So f at g at x, whatever goes in here goes into the x's. All right. So whatever is in here goes into the x's. So I'll do exactly that. G at x squared, right? I'm following this one right there. Minus g at x plus 2. Okay, so I hope that made sense. And then, of course, I've got my 9x squared plus minus 3x. I'm just grouping the coefficients. The exact same thing. Now, at this point, what do I do here? Well, g at x they give me is ax plus b. So I've got to put that in there. Ax plus b all squared minus ax plus b plus 2 is equal to that. I don't need to keep writing it every single time, because this is going to probably be several steps. Okay, let's expand this. A squared x squared plus 2abx, all right, plus b squared minus ax minus b plus 2. Okay, now let's see any like terms I can group here. A squared is my coefficient in front of x squared. And let's see, for x, what's my coefficient? If I add like terms, I'm going to have a 2ab, and I'm going to have a minus a. And then everything else is my last number there. Okay, at this point I'll put that in there. 9x squared plus minus 3x plus 2. Okay? And I say, well, okay, great. What do I do now? Where do I go from here? These coefficients all have to match. Okay? That one has to match that one, and this has to match that. So that means that this guy right here is the same as that. So a squared is equal to 9. And therefore a is equal to plus 3 or minus 3. Okay? Now in a very similar way, this guy here has to match this negative 3. So 2ab minus a has to be equal to negative 3. So if I put in, let's start with a equal to plus 3, I will get, let's factor out the a. I think that'll make it easier. 2b minus 1, like that. You don't really need to, but what the heck, right? So now we got, let's try for a equal to positive 3, what we get for b. So that's what we get. And if you divide through by 3, you get 2b minus 1 is equal to negative 1. 2b is equal to, therefore, 0. So b is equal to 0. Okay? So therefore, our first ordered pair, AB, is 3, 0. Okay? Now let's do the next one. Remember, this one we had put in positive 3. So let's now figure out the value for b when a is negative 3. So it would be negative 3 times 2b minus 1 is equal to negative 3. If you divide through by negative 3, you get 2b minus 1 is equal to 1. 2b is therefore equal to 2, and therefore b is equal to 1. So the other ordered pair is negative 3, 1. Okay? And just for the sake of completion, I want to ensure that this is going to equal 2 for both my values that I got. So first, let's try it for 0. B squared minus b plus 2 is equal to 2. If b is 0, this indeed does work. And now let's try b equal to 1. B1 squared minus 1 plus 2 is equal to 2. And there you go. That works also. So these are my two ordered pairs.